So, for the past couple of years, we've all gotten used to AI as this super smart chatbot, right? Something you talk to. Well, that's all about to change, big time. The cutting edge of AI isn't just about talking anymore, it's about doing. So let's dive into this wild new world of AI agents. I mean, really think about that. What if AI could do more than just give you an answer? Imagine an AI that doesn't just tell you how to book a flight, but actually goes and books it for you. Or one that can fix bugs in your code or run a whole research project from start to finish. That's the core idea behind agentic AI, turning these passive knowledge machines into active partners. And this slide right here, this really nails the difference. On the left, you've got generative AI. It gives you answers. It's an engine for knowledge. But on the right, you have agentic AI. It takes actions. It's an active collaborator. It's the difference between a tool that tells you how to do something and a teammate that just does it. Okay, so to really get what a huge leap this is, we've got to break down what an agent even is. Because it's not just a chatbot with a cool new name. Nope, this is a totally different way of thinking about AI. All right, so here's the more, official definition. The keywords you really want to latch onto are perceive, reason, plan, and execute. A normal large language model, the kind that powers a chatbot, it just responds to one prompt at a time. But an agent can have a long-term goal, break it down into steps, and actually interact with its environment to make it happen. Now, when you first see a diagram like this, I know it can look super complicated. You've got memory, tools, multi-agent stuff. It's a lot. But honestly, don't get hung up on that. It all really boils down to one simple but incredibly powerful core idea. Let's see how that actually works. So how does one of these agents actually, think? Well, it runs on a constant feedback loop, kind of like we do, right? It looks at the world, thinks about what to do, and then it does something. This little loop here is basically the whole game. You can think of it like a person. The agent has senses, that's how it perceives the world. It has a brain, that's the large language model, to plan what to do. And it has hands, those are its tools to actually act on the world. And this cycle just keeps going. Observe, think, act, repeat. That's what lets it handle really complex, multi-step jobs. So let's really dig into those steps. First up, perception. The agent looks at its environment. Maybe it reads some text or even sees a screenshot. Then, planning. Its LLM brain kicks in and goes, okay, based on what I'm seeing, what's my next move? Then comes the action. It uses its tools, like a browser or a code interpreter, to do that thing. And this last part is absolutely crucial, memory. It looks at what happened after its action, learns from it, and uses that new knowledge to plan the next step. The loop is complete. A single agent is powerful for sure, but the real magic, the real game changer, that's when they team up. This is where we go from having a single digital assistant to building an entire digital workforce. Yeah, exactly. It's like, why have just one digital employee when you can build an entire digital company? You could have a product manager agent that writes up a plan, then hands it off to an architect agent who passes it to an engineer agent to write the code. They can literally form a virtual company to build real things. So this first setup is what we call a chain or waterfall topology. Just look at it. It's basically a digital assembly line. One agent does its job, then passes the work to the next agent in line, and so on. It's super structured, which makes it perfect for tasks with a clear workflow like building a piece of software. Okay, next we've got the star. And it's pretty much what it sounds like. You've got this one central controller agent that acts like a project manager. It takes a big problem, breaks it into smaller pieces, and then delegates those pieces to specialized worker agents. One to code, one to review, one to test. It's all about centralized management. And then there's the mesh. This is where things get wild. Think of it less like a company structure and more like a chaotic, creative brainstorm. All the agents can talk to each other, pitch ideas, argue, critique each other's work, and even vote on the best way forward. This is where you get really creative, unexpected solutions. And look, this isn't just theory on a whiteboard. These patterns are being used right now, in real frameworks. MetaGPT uses that assembly line chain structure to build software. Microsoft AutoGen is a great example of the star, managing different tools. And Camel uses that crazy mesh setup for things like creative brainstorming. The collaboration style is picked to fit the job. Okay, so we've covered the how they think, how they team up. But what about the now? What does this all look like out in the wild, today? Let's check out the agent marketplace. And trust me, this is just scratching the surface. We're talking about autonomous software engineers like Devin that can literally take a bug report from GitHub and just fix it. We've got browser agents from folks like OpenAI and Anthropic that can see your screen and use your mouse. And of course, agents like GitHub Copilot that live right inside your coding software, acting as a full-on pair programmer. And if you're thinking this is some niche, nerdy corner of the tech world, think again. The projected market size for AI agents by 2026? Nearly $11 billion, with a growth rate of over 46% a year. This stuff is absolutely exploding. But you know what they say, with great power comes, well, a whole new set of problems. Giving AI the ability to act on the world, not just talk about it, introduces some serious risks we never had to think about with old-school chatbots. This quote from one of the papers we looked at it hits the nail on the head. When a chatbot hallucinates, you get a weird sentence. Annoying, but whatever. When an agent hallucinates, it might try to delete the wrong file, or call a function that doesn't exist, or even spend real money. The consequences are suddenly very real. So we really have to get our heads around these new ways things can go wrong. An agent might get stuck in a loop, trying the same broken action again and again, or, and this is a scary one, it could get hijacked by hidden malicious code on a website it's visiting, a thing called prompt injection. That can turn our helpful assistant into a confused deputy doing a hacker's dirty work without even knowing it. And this chart shows a really important trade-off we're facing. Look at the agents in red. They're the most powerful, hierarchical ones. They do the best job on things like reasoning and using tools. But look at the cost efficiency axis. They are way more expensive to run, and all that complexity can make them harder to keep safe. So it looks like there's no free lunch. So when you pull it all together, what are we really looking at here? It's nothing short of a fundamental evolution of computing. We are moving away from an AI that we just consult and toward an AI that we work with, side by side. It's a shift from asking for information to delegating an entire outcome. And that really leaves us with the big final question, doesn't it? As these autonomous agents move out of the lab and into our everyday work, becoming our digital colleagues, the biggest challenge isn't just going to be technical. It's going to be social. How do we build these things so that they're not just capable, but also reliable, secure, and ultimately worthy of our trust?